Hello, dear student. Now we are going to see the topic called triangle. Now in the triangle, first of all, it is divided into the four sections. First, we have to read about the similar figure and similar triangle. Now in the similar figure, similar polygon, similar triangle and BPT theorem. This is the first part we are going to see. After that, criteria for similar triangle. For that, triple A, triple S and SAS criteria. After that, we will see area of similar triangle and Pythagoras theorem and its converse. So this is the total syllabus that we have to read in the class 10th. So first of all, we will start congruent figure. Two figures are said to be congruent only when their shape and size are same. Two geometrical figures which have the same shape and same size is known as congruent figure. That means congruent means it is alike in every respects. Every respect, the two figures are congruent. This is congruency of the figure. Same shape, same size, same angle, each and everything is same. Then we can say this is congruent figure. But similar figure, the meaning of similar figure geometrically, the geometric figure which have the same shape, it will look same, but size is not same, size is different, then it is called similar figure. So this is the difference between the congruency and similar figure. Here shape is same, but different size, and here the size is also same. Now, from the figure, two congruent figures are always similar, correct? But two similar figure need not be congruent. Now from the example just we see, these all are similar figure. They have the same shape but different sizes. Now similar polygon. What is the meaning of similar polygon? Two polygon having same number of sides are said to be similar. If it is a polygon, then first thing is two polygon having same number of sides are said to be similar if their corresponding angle are equal. First thing is their corresponding angle are equal, and second is length of their corresponding sides are proportional. This is the two important thing for the similar polygon. Their corresponding length are equal and corresponding sides are proportional. So in this way, it is, we can say, similar polygon. Now suppose the polygon we are taking here, ABCDE and PQRST are similar, then from the above definition, what we can say, corresponding angle, that is angle AP, BQ, CR, DS and ET, these all are same. Angle A is equal to angle P. Similarly, B equal to Q, angle C equal to angle R, D equal to angle S. This is the first thing. Second thing, their ratio. So suppose we are taking AB, then here we have to take PQ. If we are taking BC, then we have to take QR. If we are taking CD, then we have to take RS ratio. If we are taking DE, then we have to take ST. And if we are taking EA, that is EA, then we have to take TP. So ratio and angle both are, first is in the angle is same, second the length of the ratio of the sides are same. So we are representing these two in this way. This is the representation when the two polygons are similar. So these two polygons are similar, then we can write like this. Now first of all, we have to check these two polygon. This is 5 sides, they are similar or not. So here 3 centimeter, here 4.5 centimeter. So this value is 3 divided by 4.5. So we can write this is 2 by 3. 4 and 6, 2 by 3. 3 and 4.5, 2 by 3. This is also 2 by 3. But what about the 3.2 and this is 3.2 divided by 4.8. This is not 2 by 3. This is also 2 by 3. 16 2 jar, 16 3 jar. Now, this is first thing is this. Now, after that, we have to see the angle 130 degree, 130 degree, 100 degree, 100 degree, 120 degree, 120 degree, 90 degree, 90 degree. So whatever that this value, it is same. We can find out the angle. Similarly, this also we can find out the same pattern. This is 3 centimeter. So you see the diagram. You may note that in the two quadrilaterals, a square and a rectangle, a square and a rectangle here of corresponding angle are equal, but their corresponding sides are not in the same ratio. This is equal, but they are not in the same ratio. This is 3, 3.5, this is 3, and this is 3. So this is not in the same ratio. So this quadrilateral are not similar. Similarly, you can judge here ratio and angle. So two quadrilaterals are not similar. Now, the most important thing is the constant ratio between the corresponding sides of two similar figure is known as scale factor. The constant ratio between the corresponding sides of two similar figure is known as scale factor or representative fraction. That also we can tell representative fraction. Since triangle are polygon, so same set of condition we have to apply for the similar triangle. Now, equiangular. Two triangles are said to be equiangular if their corresponding angles are equal. Now, similarly, similar triangle we are telling two triangles are similar only when their corresponding angles are equal and corresponding sides are proportional. This is the two important thing. Corresponding angles, corresponding sides, that is the criteria for the similarity of any polygon. So triangle is also a polygon, so definitely it will follow the same rule. So if in the figure we will see this is the two triangle. So in the two triangle, angle A, angle D, whatever the angle, angle B, angle E, angle C, angle F, and the corresponding sides are in the same ratio. So AB by DE equal to AC by DF equal to BC by EF. Now, the ratio of any two corresponding sides in the two equiangular is always same. We will see some problem. Now, ABC and PQR are two similar triangles. Corresponding value of AB and PQ is given, and perimeter of the triangle is 60 centimeter. Find the perimeter of PQR. We have to find out the perimeter of PQR. Now, if this is similar, then the first thing is their ratio is same. First, we have to write down the ratio. So here, AB by PQ. AB by PQ value is given 6.5 that divided by 10.4, that is we can write 65 by 104 because this decimal will go. Now, if what is given perimeter, find the perimeter of PQR. This perimeter we have to find out, and the perimeter of this is given. So this is very important question. Now, we can write here AB equal to 65 by 104 into PQ, BC equal to and AC equal to. So one triangle we are representing in the terms of other triangle with the whatever the scale factor is there. It is, now this is the value. Now triangle ABC perimeter is 60. First of all, we have to write. After that, from here, just we have to substitute the value, and this value is the sides of other triangle. So once we will add this and solve this, we will get the value of PQ, QR, and PR, sum of this value, that is 96 centimeter. Now, question number 2, it is given that these two triangles are similar. If these two triangles are similar, AB, AC, and DF, DE all are given. Find the length of remaining sides of a triangle. So first of all, once we draw the two triangle ABC, DEF, so this is the nothing but the similar triangle. So AB by ED, we can write AB by ED equal to AC by EF equal to BC by DF. So whatever the value is given, first of all, we have to write and just we solve. Easily we can solve first two, then we get the value of EF. After that, just first two you can solve, first and third you can solve, we will get the value of BC. So in this way, we can solve the value. Now, question number third we will see. Now in this figure, find the value of H in that. This is the given figure. And find the value, we have to find out the value of H in that joining figure at which tennis ball must be hit, where the tennis ball must be hit in this, so that it will just pass over the net. It will just pass over the net and land 6 meters away from this. This is nothing but the net, and land 6 meters away from the base of the net. This is the base of the net, and this is 6 meters where it will land. Now, this is given H height, and EDA is nothing but the 90 degree. Now we will assume this net is nothing but in the vertical. Now, triangle ADE, this triangle ADE and ABC, this is nothing but the similar and equiangular. So based on that similar triangle properties, first of all, we can write DE. This is the bigger length of that bigger triangle. DE by BC equal to AD by AB. So just we have to substitute the value here. H divided by 0.9, 18 divided by whatever the value. So this value is 2.7 meter. So height at which the ball should be hit is 2.7 meter. This is the answer. So I hope this similarity of the triangle and similarity of the polygon is crystal clear for all of you. Thank you.